Hello everyone, welcome back to Sarana Safety Prep. Today we're tackling part 2 of the Trigonometry chapter of the College Panda math book. So let's start with question 7 here. If sine x is equal to 0.25, what is the length of BC in the triangle above? So since sine x is 0.25, we can also represent it in terms of fraction. So sine x can be also represented by 1/4. And now all we have to do is remember that sine is opposite over hypotenuse. So the opposite of this angle is 3, and the hypotenuse is this side BC that we do not know. So we can represent this as 3 over BC is equal to 1/4. Now we can cross multiply, so you get 12 is equal to BC. So the answer to this question is 12. In the figure above, right triangle ABC is similar to right triangle MNO, with vertices A, B, and C corresponding to the vertices M and O, respectively. If tangent B is equal to 2.4, what is the value of cosine N? Again, here it's testing our knowledge of sine, cosine, and tangent. And we know that tangent B is 2.4. We need to remember SOHCAHTOA. So tangent is opposite over adjacent, so we can represent that as opposite over adjacent. B is equal to 2.4, and we can also represent 2.4 in terms of a fraction, just so it's easier for us to cross multiply. So 2.4 is also equal to 12/5 as a fraction. Now let's look at our triangle, our smaller triangle here, and we're looking at it in the terms of the B angle, and the opposite of the B angle is the side of AC, and AB here is our adjacent side. So using our Pythagoras theorem, we can kind of find BC, because we know that AC here would have to be 12. Right? So AC has to be 12, because if you do AC over AB, then we know that AC is 12 and AB is 5. So AB is 5. Okay, now if you know our properties of the triangles, we know that this hypotenuse must be 13. It's a common triangle, 5, 12, 13, same as 3, 4, 5. However, you can also use the Pythagoras theorem to find the hypotenuse. So you can do 12 squared plus 5 squared is equal to x squared, where x is the hypotenuse. And then you can later solve, and you also get the same answer, 13, for BC. So now we know that BC is 13. We know that AB is 5 and AC is 12. We can now solve for the value of cosine N. And the reason why we can do that is because the two triangles are similar. So we can say the cosine of N is the same as the cosine of B, because they are both similar. And the cosine of B is, again, opposite over hypotenuse, right? So the opposite angle of, in terms of B, is what? The opposite angle. Okay, yeah. So basically cosine, right? So it's the adjacent angle, my bad. So the adjacent angle in terms of B is the one next to it here, which is 5, or AB. So AB over the hypotenuse, which we have as BC. And now we can just plug in our values, so it's 5/13. So the answer is 5/13 for question 8. Question number 9, cosine 32 is equal to sine 5m minus 12. In the equation above, the angle measures are in degrees. If 0 degrees is less than m, so m is between 0 and 90 degrees, what is the value of m? So to compute the exact value of m, we need to remember this property of cosine and sine x. So we can represent cosine x as equal to sine 90 minus x, right? So they're both equal. And then, therefore, we know that cosine of 32 is basically sine 90 minus 32, which will give us 58. So they're both in degrees, and we know that they're both set equal to each other. Now all we have to do is we can replace this cosine 32 with our sine 58 and solve for m. So therefore we have sine 58 is equal to sine 5m minus 12. And now all we have to do is we can cancel out the signs. So cancel out the signs, and we're left with 58 is equal to 5m minus 12. Now we can use simple algebra to solve for m. So move the 12 to the other side. We get 5m is equal to 70. And m is equal to 70 divided by 5, which will give us 14. So the value of the answer to this question is 14. Question 10, we have this right triangle ABC that is shown in this xy plane. We need to calculate the value of cosine C. So we are given the coordinates of A and C, and we can use that to kind of solve and deduce what our sides is. And here, if we look at B, we're not given the coordinate of B, but we can kind of guess where it is. Because here we can see that A has a negative 3 as x value. So we know that B's value is also negative 3, because they have the same location in terms of x. So B seems to be negative 3, comma, negative 3, which is our y value for part C. So now we have all the coordinates. We can find the side of AB here. So the side of AB is 5. We need to take the y values and subtract them. So it's 5 minus 3. So we'll get 8. And let's look at BC here. And BC is between 12 and 3. So negative 3 to 12. So negative 3 to 12. So basically it's 15. We can also do negative 3 minus 12 minus negative 3. So it's 12 plus 3, so we get 15. And remember that the side lengths cannot be negative ever if it's a triangle. So now we know that the side AB is 8, and we know that side BC is 15. We can again use the Pythagorean theorem to find the side of AC. So again, we can represent this as AC squared is equal to 8 squared plus 15 squared. And now we can do a root to both sides. And then we can first expand the 8 squared and the 15 squared, and we add it together. So we have 15 squared. So AC squared is equal to 64 plus 225, which is 15 squared. And AC squared is equal to 289. And now if you root both sides, we'll get AC is equal to 17. So now we have the hypotenuse, and the value of the hypotenuse is 17. Now we can go ahead and compute the value of cosine C. So cosine C is again, so katoa, right? So it is adjacent over hypotenuse. So in terms of the angle C here, and the adjacent side here is BC. So it's BC over AC, which is the hypotenuse. So we get 15 over 17. So our answer is D. Alright, let's move on to question 11. In the figure above, AC is the diameter of the circle. If AC is equal to 1, which of the following gives the area of a triangle ABC in terms of data? So the angle here, ABC here, should measure 90 degrees, because every time the triangle is inscribed in a semicircle, this angle is always 90 degrees. So that's something you must remember. And thus, because we have a 90 degree angle here, I think it's better to represent it in terms of a square, like so. Because we have a 90 degree triangle, we know that ABC is a right triangle. So now let's let the height of the triangle ABC be AB. So let's denote this as the height. And the base is just BC. And we know the hypotenuse is 1, right? Because we're given that AC is equal to 1. We can represent sine theta as AB, right? AB over 1, which is the same as AB. And cosine theta is BC over 1, so it's BC. Now all we need to do to compute the area of a triangle is basically do 1 over 2 times base times height, and our height value is AB, and our base value is BC. And we know that in terms of cosine and sine, we represent AB and BC, so we can just substitute that value in. So we get 1 over 2 times cosine theta times sine theta, and that's basically cosine theta sine theta over 2, which is answer choice D. Alright, let's move on to the final question of the day. Given that sine theta minus cosine theta is 0, where theta is the radian measure of an angle, which of the following could be true? Number 1, that theta is between 0 and pi over 2. 2, that theta is between pi over 2 and pi. And third, that theta is between pi and 3 pi over 2. So essentially, if you should be familiar with these values here, because they represent the quadrants of which the angle theta can be at. So sine theta minus cosine theta is equal to 0. So we can rewrite this as sine theta is equal to cosine theta. So essentially the question is basically asking us which quadrants exist where sine theta is equal to cosine theta, right? So for them to be equal, they must have the same side, right? So this rules out option 2, because in this quadrant, sine is positive and cosine is negative. So this is the second quadrant, so that rules out option 2. Let's look at quadrant 1, which is option choice 1 here. And here, we know that sine and cosine are both positive, and sine is also equal to cosine when theta is 45, right? Because it's a 45, 45, 90 degree triangle. So we know this one is true. Let's look at the third one. And this is the third quadrant where also sine and cosine are both positive. So this is also correct. So the answer is C, A, and number 1 and number 3. Yep, that is all. And I hope you guys enjoyed this video, and I'll see you on the next one.